Okay, so let's look at these extra examples of quadratics, just so that you have them in case you need to go back over them. So remember, the first thing we always do is we always identify the vertex. Okay, so our vertex, let me get a colored pen so we can see it. Our vertex is going to be right there, and I usually put like a plus on top of it, and they're right there. So there's my vertex, and it is at 0, -7. Okay, on the table, let's do the graph first and then we'll do the table. Okay, so then on this one, when I look at my vertex, right, so I found my vertex. Now, the next thing I can use, so from the vertex, immediately from the vertex, I can find my axis of symmetry, because remember, it's x equals, so it's the x and the vertex. Well, the x and the vertex is 0, so it's x equals 0. That's my axis of symmetry. Okay, so again, if I were to draw a line down the middle of this parabola, let me get a pen I can actually see. If I were to draw a vertical line down the middle of this parabola, that will be my axis of symmetry, and the equation of that line would be x equals 0. Okay, so there's my axis of symmetry. All right, I can also identify my x-intercept, well, my x-intercepts and my y-intercept. Now, my x-intercept is easy to find, right? Because, my y-intercept. My y-intercept is 0, -7, which happens to be the same value as the vertex. Now my x-intercepts are a little trickier here, because if you look, let me zoom in. Okay, if you look, it's my x-intercepts are between, so I have 1, 0 between, I'm just going to put BTN for between 2 and 3. I've got another one between -2 and -3. Now, it's closer to 3. It's closer to -3, so I'm going to circle -3. I'm going to circle +3. That way, if I'm looking at answers and they have like 2.2 and 2.8, I'm going to pick 2.8 because it's closer to 3. Kind of make sense? Okay, so what are my other key features? Well, I have, my notes say that my other key features are vertex, symmetrical pairs, axis of symmetry, y-intercept, and x-intercept. I've got everything right now except symmetrical pairs. So I can just find some symmetrical pairs, right? So I can see one right here, it looks like. There's a set of symmetrical pairs. And then looks like right here, and again, I'm just looking at integer symmetrical pairs. And then it looks like there's another set right up there. Okay, so these are at -4,9 and 4,9. These are at -3,2 and 3,2. These are at -3 and -2, -3 and 2, -3. Okay, so that's how I would find it on the graph. Okay, now the only information I can get out of this equation, first of all, from the equation, let me just grab another color pen here. That's not going to work out. Let me pause real quick to find another color pen. No, I can't do that. Here, found one. Yay. Okay. So let's look at this equation. From the equation, I can tell that it's two things. I can tell that it's quadratic because it has an x squared as its highest exponent, and I can tell that its y-intercept is -7 because that's the constant. The constant is always the y-intercept. Okay, so that's all I can get from that equation. Now let's look at the table. Remember, from the table, we're always going to be able to identify our vertex. Now, I know I told you that what I do is I start by finding like but what I actually do is I start by connecting y values together. Okay, you see how I can connect these y values together? Okay, these are my symmetrical pairs, right? Okay, well, for my symmetrical pairs, whatever's in the middle of my symmetrical pairs, that's my vertex. Okay, since it starts with 0, it also happens to be my y-intercept. So I'm going to label it with a y and a v. Now, I'm also going to try and find my zeros. Now, I don't see anything with a y value of 0, but do you see how right here it went from 2 to -3, so it passed through it passed through 2 and went to -3? This right here, that means I have a 0. Right here, there's a 0. And see here it went from -3 to 2. That means it had to go through 0 to get there. So I have another 0 here. And that matches up with what I had here, right? I said I had a 0 between 2 and 3. And I had another 0 between -2 and -3. Okay? That's the information I can get off of there. Now, there's one other thing that I can get that I couldn't get from up here, which is, do you see down how down here I have 7, that 7 also doesn't have a partner. But it does, because it's not the vertex. That means it has to have a partner. So what I can do to find that partner is I can go, okay, well, all right, to get from, the pattern is like to go back in the other direction, I'm going like -1, -1, -1. Well, -6 minus 1 is -7, all right? And then if I continue the pattern to get to that point, 42, it has to have a 42, because remember, they have matching y values. Okay, so I can figure out any values that aren't the vertex if I have the matching symmetrical pair on the other side. Okay, I'm going to do this one example because well, you know what? Let's do one more. Let's do one of these negative ones down here. Okay, so first of all, oh, and that's another thing, really quick, something that I didn't say that you can tell by looking at this one. You see how there's the vertex is the lowest point we get to? That means this vertex this graph has a minimum. It has a minimum, which means it has a lowest value. Okay? And what that also means is that it opens upward. We also call that concave up. I know that's crazy, but I've seen it referred to that way. I'm just giving you every way I can think of. Now, how can I tell that from this graph, from this here? Okay, well, the way that I can tell it from here is if I look, you see how, like, as the values, so I look at what's happening to the y values as they move away from the vertex. Remember, y goes up and down, right? Well, -7, -6, -3, 2, 9, 18, 29, they're getting bigger. As they move away from the vertex, they're increasing. And even in this direction, as they move away from the vertex, they're increasing. That means we're opening up. Okay, so let's look at this one and let's kind of compare that. All right, so first of all, pause the video for a second, see what you can find on the graph of the features. Okay, so for me, here's what I find for the features. First of all, I see that I have a maximum this time. Okay, actually, you know what? Hold on, hold the phone. I don't want you to do that. I want to do this one because this one does not have, the vertex is in a different place. Let's look at this one. So I have a maximum right here. Okay, I have a maximum. Okay, now, when I look for the vertex is right there, okay, at 3, 6. The vertex is not always going to be on the y-axis like it is here. Sometimes the vertex is going to be on, it's going to be like off to the side, okay? So if I have a maximum, maximum, that means it opens down. And sometimes I'll say it points down, and when I say it points down, what I mean is the arrows are pointing down, okay? So you might say points down. Because again, the arrows are pointing down, not the vertex. The arrows are pointing down, and then we might also say concave down. Yes, we might say convex up, but that's for a whole nother course, a whole different course. Okay. Now, likewise with this one, I can't exactly find my zeros, and that's okay. Let's start with our y-intercept. Okay, I can't even find my y-intercept on here. But if I look at the table, I can figure out with what. So I can't see the y-intercept, but is there going to be a y-intercept? Yes, because if you look, as I go down, I'm getting closer and closer. So even though I can't see the y-intercept, I know there's going to be one because this graph is going out as it goes down. Eventually, somewhere way down the line, it's going to cross. So I can't see it on the graph, but that doesn't mean that it doesn't exist. It's got a y-intercept. I just can't see it because I ran out of grid. Remember, just because I ran out of grid, it doesn't mean I ran out of graph. Okay? I ran out of grid. Okay? So if I could zoom this thing out, which I can't, but if I could, I'd be able to see where it crossed. All right? So now again, when I look at my, well, I can also find my axis of symmetry. Okay? Because remember, the axis of symmetry is the x in the vertex. Okay, so my axis of symmetry is x equals the x in the vertex 3, and that's a vertical line going through 3, which is exactly what I've got. So my axis of symmetry is x equals 3. Okay. Oh yeah, that looked crazy. Okay, great, go me. Okay, so what else can I tell from this? I can tell that my zeros, I have 2 because I can see it crossing in 2 places. Now I'll tell you right now, we won't always have 2 zeros. Sometimes we might have 1 0, sometimes we might have no zeros. All right? And I can show you, actually, you know what, I'll show you what that looks like here on one of these other graphs. But I might have 2 zeros, I might have 1 0, I might have no zeros. Okay, so I will have up to 2. So whatever the highest coefficient is, that's how many zeros I could have. 0, 1, up to that number. Okay, so my zeros, I see 1 between 2 and 3. Okay, and it looks like it's a little closer. Oh, nope, I lied. That's between 1 and 2, and it's a little closer to 2, so I'm going to circle 2. I see another one between 4 and 5. This time it's a little closer to 4, so I'm just going to circle the 4. And again, I do that because if I'm looking at multiple choice answers and they give me 4.2 and 4.8, I'm going to pick 4.2 because it's closer. All right? And that's pretty much what I can tell from looking at this one. I don't really symmetrical pairs. Hold on, let's find some symmetrical pairs. I think there's one here at 2, 2, like right here. At 2, 2, and 4, 2, there's one. Looks like there might be one at 7. No, wait a minute. No. It's down here at 10. So I have one at -1, 10, and 5, 10. And these are far apart because this is very stretched out. It's very tall. We'll learn about learn about the transformations here soon. Now let's look at the equation. Okay, so from the equation, all I can tell from looking at this equation is, number 1, because it's the highest exponent I see is a 2, I can tell that it's quadratic. Okay, that's the first thing I can tell. The second thing I tell is that it's got a y-intercept of, -30, because C, my constant, is -30. That's a 3, by the way, before you go getting all crazy. What is that? It's a 3. Okay. Now the third thing I can tell right now is, since it says minus, that means, since this is negative, A is negative, that means it's pointing down. Okay, if that was positive, see how up here x squared was positive? That's why it was pointing up. Since x was negative, it's pointing down. And we're going to learn that this -4 actually means that it's stretched. That's why it's so tall and skinny, is because it's vertically stretched. Which, yeah, that's coming back. Okay? It's vertically stretched. So that's all I can tell. The 24 and the 30, the 24x doesn't really tell me much, except that it's not on, the fact that it's got a B usually tells me, it tells me it's not on, what's it called? It's not on the, oh my God, what am I trying to say? Oh, it's not on the y-axis. Okay? So that's what I know. Okay, so let's look at this last one because this is going on really long. Again, I'm going through these very slowly. This is an optional video, so if you got bored by now and tuned it out, that's your business. Okay, so I start by connecting up my symmetrical pairs. I see 2 and 2, -10 and 10. Well, that right there is enough for me to know that the one in the middle that doesn't have one, that's my vertex. Okay, so my vertex is at 3, 6, just like I found in the graph. Okay. I can also see my Y-intercept right here. My Y-intercept. Now I'm not calling it B because it's not B. It's C in a quadratic, so I'm just calling it Y for my Y-intercept. Okay, now I'm looking for my zeros, okay? So I don't see 0, but I see that it went from -10 to +2 right there. I got a 0 right there. And I can see that my Y values went from -2 to -10 right there. So I have a 0 between 1 and 2 and between 4 and 5. And I can see that there. Okay? Now, what else can I see? I can see my axis of symmetry is x equals 3 because that's the x and the y, the x and the vertex. This will tell us something tomorrow. The y and the vertex will tell us something tomorrow. It actually tells us our minimum value or maximum value. Now, that's speaking of which. As I move away from the vertex, what's happened to these values? They're decreasing. As I move away from the vertex, they're decreasing. That means I have a maximum and it's opening down. Okay, I have a maximum and it opens down. Okay, now I also see again here, if I connect these up, I'm sorry, I'm not trying to get too neat here. I see I have a buddy with, I have one that doesn't have a partner, right? Well, I know that if I move this up to, let's just say right there, there should be a -190 here. Well, if I continue this pattern, 0, -1, -2, -3, -4, that means its symmetrical partner is -4, -190. Okay? And that's about all the good information I can get off of there. Okay?